So pretend you were asked this on a major assessment. Which of the following are factors to x to the fourth minus 20x squared plus 64? Select all that apply. Well, I could try to factor this, and maybe I could do it, but factoring can be something that's hard as things get bigger. So I could also write this down for division, but one thing I have to keep in mind, there's no cubic term, and there's no x to the power of 1 term, so I need to have placeholding zeros for those. Otherwise, I could use synthetic division, 1, 0, negative 20, 0, and 64, and I could just start dividing by the zeros. If negative 4 is, or x minus 4 is a factor, 4 would be the 0. Bring down the 1, 4, 4, 16, 4, 4 times 4 is 16, 16, 4 times 16 is 64. I was so close that I looked back and realized that negative 20 and 16 was a negative 4, making these negative 16, this negative 64, and 0. So I know that 4 is a 0, x minus 4 is a factor, but I can also start again with the same leftover polynomial with a new factor to see if others work. Maybe I'll try negative 4 now. When I try this, I'll bring down the 1. Negative 4 times 1 is negative 4, add 0. 0, add negative 4. Negative 4 times negative 4 is positive 16. I get a remainder again. So this was x cubed, x squared, x, and a number, meaning this is x squared, 0x minus 4. So that means this is a factor, and what's left is just x squared minus 4. Well, now I can see that factors into x minus 2, x plus 2. And that allows me to see that these two are also factors without doing any more division, and I can rule out all of these because I've found my 4 factors that got me to a 4th degree polynomial. So synthetic division can also be really helpful factoring if that's ever a challenge for you. The final answer then, if you were ever asked for it in fully factored form, is this, and we could also easily graph it because we know the 4 zeros, we know its end behavior, and we know the multiplicity of each 0 is 1, so there's always crossing, never bouncing.